In this video, we're going to be solving equations containing rational expressions. So when you're solving these equations, what we want to do is multiply both sides of the equations by the LCD. So we're still going to be finding that LCD, but instead of taking them and creating a common denominator, we're going to multiply everything by that LCD. And what's going to happen is it's going to get rid of the fractions. And so once we do that, we're going to remove any grouping symbols by distributing when necessary. And then we're just going to solve the resulting equation. This last step is super important. Sometimes people want to skip this step, but checking your solution in the original equation is really important. And the reason is you could have what's called an extraneous solution. And that means that it's a solution that you might have gotten and you didn't do anything wrong. It just doesn't work because it's not in the domain, okay? And if you remember, what that means is it makes the denominator equal 0, and we can't have that. All right, so let's look at some examples. So if we look here, we've got 3 different parts, and our denominators that we see are both x's. Remember, 7 is over 1. So our LCD is x. So what that means is I'm going to multiply everything here by x. I'm going to multiply x here. I'm going to multiply x here. And I'm going to multiply x here. I'm multiplying the entire equation by x. Okay? And I like to write it the way that I just did. You may see people that just say, okay, we're going to multiply everything by x. But I find that if you write it with every single piece, it's easier for you to keep track of what you have canceled and simplified as you go through. What I mean is, I can see that, okay, x, remember this is x over 1, right? This x and this x cancel. And so the only thing I have left is 27 equals, well, there's nothing to cancel in this one, so I have 7x minus this x and this x cancel, 1. Now I have a pretty basic equation to solve. I'm going to add 1, divide by 7, and so x equals 4. Now, if I take this 4 and plug it back in, it should work, right? So I would solve that, check my answer. We would simply do this. And does that work? Right? That's what we're checking. Another thing that you're really looking for when you're checking is if you plug it in the denominator, does it give you a 0? Okay. All right, so let's look here. So we've got 2 denominators here. What would that LCD be? Okay, so can't factor anything, which tells us that our LCD just needs to be a combination of the 2. So I'm going to multiply everything by t times 5t minus 12. So t 5t minus 12 and t times 5t minus 12. And so what happens in this one, the t's are going to cancel. And so I have that 2, but I also have 5t minus 12. In this one, the 5t minus 12's cancel. And so I have t times t, which is t squared. Okay, so I can start solving. So 10t minus 24 equals t squared. Anytime you have a quadratic, we're going to set that equal to 0. So I'm going to move all these over. I'm going to subtract 10t. I'm going to add 24. And so that leaves me with 0 equals t squared minus 10t plus 24. Okay, back to our good old friend factoring. So I've got t minus 6 and t minus 4. And I know I can set both of these equal to 0. So either t is going to be 6 or t is going to be 4. And I need to make sure that these solutions do not give me a 0 in my denominator. And they don't, I'm good. Okay. All right, so here I've got a 6 and a 7. So my LCD is going to be 6 times 7, so 42, which means I'm going to multiply each one of these by 42. And so what happens, this simplifies with this, making that just have 7. So 7 times x plus 5. Here, this simplifies, making that just be 6. So 6 times x plus 6. Now we simplify and solve. So 7x plus 35 equals 6x plus 36. I'm going to subtract 6x. So x plus 35, goodness, equals 36. Subtract 35, so x equals 1. Again, I would check to make sure I don't have a 0 in the denominator, and I don't, so I'm okay. All right, here, again, we're going to start by finding our LCD. So my denominators, I've got 1x and x squared, which means my LCD is going to be x squared. So I'm going to start by multiplying every single term by x squared. My first one, there's nothing to cancel, so that's just x squared times 1, so x squared. Second one, I can cancel this and one of those x's, so I just have plus x. Here, x squared and x squared cancel, so I've got 90. Got another quadratic, so I'm going to set equal to 0. So I'm going to move that 90 over, so minus 90. We want to factor that out, so x minus 9, x plus 10. So x equals 9 and x equals negative 10 are my solutions. And again, we're going to check to make sure they don't give us a 0 in the denominator. Okay. All right, example 5. Now look for that LCD. So here my denominators are A, 4, and A. So that tells me my LCD is 4A. So I'm going to multiply by 4A. Now I'm going to clean it up. So that cancels with that. And I've got a 4 left with 5 minus A. 4 cancels. So I've got plus 3A. The A cancels. So I've got 4 times 7. So let's start working it out. So 20 minus 4A plus 3A equals 28. So now I've got 20 minus A equals 28. Negative a, I'm going to subtract that 20 equals 8, which means that a is negative 8. Again, if I plug that in, it does not give me a 0 in the denominator. All right, let's look at this one. So I got to do some factoring in order to get my GCF. Y plus 4 and y minus 4 are okay, but here I'm going to factor that into y minus 4 and y plus 4. So that means that my GCF, or sorry, my LCD is going to be y plus 4 and y minus 4. So I'm going to come through and multiply everything by y plus 4, y minus 4. Again, you don't have to write it out every time. That's just something I like to do because it helps me see what I've canceled and see what I have. So I can say I can cancel y plus 4 with y plus 4. And it's very clear to me that I've got a y plus 4 left, or sorry, y minus 4 left, and I've got a 2. Then in this one, I can see, okay, the y minus 4 and the y minus 4. So I can see that I've got a minus y plus 4, and I've got a 6. And then here, that cancels, that cancels. So the only thing I've got left here is a 4. Now we clean up. So let's see, 2 can go through. So 2y minus 8. The 6 can go through, but we got to make sure we subtract that. So I'm actually going to rearrange this order so I can put that negative 6 through. So minus 6y and minus 24. Just watch your signs. All right, so now if I clean that up a little bit more, I've got 2y and minus 6y, so that leaves me with a negative 4y. I got minus 8 and minus 24, so that leaves me with a negative 32. I'm going to add that negative 32, so plus 32 to 4 leaves me with 36. Then I'm going to divide that negative 4, so I get y equals negative 9. And again, that does not give me a 0 in my denominator, so I'm still okay. All right, 2 more like this. Again, I'm going to start by factoring. So 2x plus 1, 4x plus 1, and then x plus 1. All right, so LCD. Well, I know it's got to have the x plus 1, right? But this time I've got a 2 and I've got a 4. So 4 is 2 squared. So I know it needs to be 2 squared. So we're going to say that our LCD is actually 4x plus 1. So when I go through, I'm going to multiply 4x plus 1, 4x plus 1, 4x plus 1. Okay. Now we clean it up. So the x plus 1's cancel. The 2 makes this 4 become a 2. So what I've got in this first term that's left, I've got a 2 and I've got an x. And that's it. Okay. The x plus 1 goes away. The 4 goes away. So the only thing I've got left here is just a negative 2x. Then the x plus 1 goes away. I've got plus a 4 and a 2x minus 3. Okay, so 2x, negative 2x, plus 8x minus 12. I'll combine those x's. So 6x minus 12. Subtract that 6x, so minus 4x equals 12, negative 12. So then divide, so x equals 3. Okay, last one like this. Can't factor those first two, but I can factor this one. So that's going to factor into x plus 5, x plus 7, and that's actually going to become my LCD. So when I go through and I multiply, each piece, okay, so the x plus 7's cancel. So in that first term, I've just got x plus 5 times 1, which doesn't change anything. Then this will cancel. So then I've got plus 4 times x plus 7. And then that goes away, that goes away. And so I've just got the negative 2 left. All right, so now let's clean this up. So plus 4x and 28. So then I've got, let's see, 5x. I've got 33. Can subtract that 33 over. Divide by 5. So I get negative 7. Okay, but let's take a look at our problem. So negative 7, if I were to come over here and plug in a negative 7. Oop, I forgot to write the negative 7. That's going to give me 0. I can't divide by 0. So this one right here, we didn't do anything wrong. It just doesn't work. So this right here is an extraneous solution. So we would put no solution for our actual answer, okay? So make sure again that you're checking these because otherwise we would not have found that. All right, so one more thing in this video we're going to cover, and that is if you're asked to solve for an indicated variable. So here we don't have any numbers, right? We just have some variables. And what we're going to do is we're going to solve for a specific variable. So here we're trying to solve for Q. That means that we need to get this by itself. So what we're going to do is move it around until it's by itself. So it's in the denominator. If it's in the denominator, I need to get it out. To do that, I need to multiply. I'm going to multiply both sides by Q. Okay, because that will make these go away, but it will also get rid of that fraction. And the reason that it does that is because now I can divide by t, make that t go away, and I'm left with just Q equals V over T, which is what I wanted. Okay, here I'm solving for H. Means this is the one I want to get by itself. Okay, so again, I need to get rid of that 3. I need to get that over. So I'm going to multiply by 3. So I've got 3V equals VH. So these are being multiplied. So if I'm trying to get H by itself, I'm going to divide by B. They cancel. So H equals 3V over B. Okay. All right, this one. We're trying to get A by itself. So this one's got a little bit more stuff going on, but that's okay. We're going to take it one step at a time. We want to get rid of that 2. So we're going to multiply both sides by 2. So I've got 2A equals H times A plus B. All right, I'm still trying to work my way to this A. That H is in the way, so let's get rid of it. This is saying H times A plus B. So I'm going to divide by H because that will go away. So I've got 2A divided by H equals A plus B, and I can drop those parentheses now because I don't need them anymore. So now I can simply subtract B from both sides, and I've got A by itself. So this is 2A over H minus B is equal to A. All right, here we go. This is the toughest one. Okay. I don't know if I have enough room right here beside it, so I'm going to add another page. Okay. All right, so let's start by getting rid of the denominator. Same thing we've done each time. Okay, so we've got I equals NE over NR plus R. And we're trying to get N by itself. Well, notice there's 2 N's. We need to get N equal, so we've got to make it 1 N. That's fine, we can do that. We're still going to start out by getting rid of this denominator. So I'm going to multiply this denominator on both sides. When I do that, it's no longer a fraction now. Okay, and so I've just got NR plus R times I equals NE. Okay, so I've still got 2 N's. I need to get my N's together if that's what I'm trying to solve for. But this one on the left is kind of trapped. I need to get rid of those parentheses. So to do that, we're going to distribute this I through. Okay, so we're going to say that this is now I times NR plus I times R equals NE. So now that N is no longer trapped inside those parentheses. I still have 2 of them, right? I've got one here and one here, but I've got these 2 separate N terms that I can start moving around. So I'm going to move this one over here so that they're on the same side. So I've got I R equals N E minus I N R. So now I've got my 2 N's. They're on the same side. I need to take them and write them as 1. So now we're going to factor. I'm going to factor out the N. So I R, I'm going to take that N and treat it like it's a GCF. That leaves me with E. And here it leaves me with I R. So now I'm really close because I've got my N written as 1 N. And I've got N times E minus IR. So I can divide both sides by E minus IR. I know it looks weird, but dividing anything by itself makes it cancel and go away. So N is now the only thing on this side. And on this side, I've got IR over E minus IR. And that's it.